What is mass, energy equivalence, and why is it often summarized by one of the most famous equations in science, E = mc²? This concept, introduced by Albert Einstein in 1905 as part of his special theory of relativity, reveals that mass and energy are not separate things, but two forms of the same physical reality. Mass, energy equivalence states that any object with mass inherently contains energy. Even when an object appears to be completely still, it possesses an enormous amount of stored energy simply because it has mass. The equation E = mc² explains this relationship. Energy, E, equals mass, m, multiplied by the speed of light squared, c superscript 2. Since the speed of light is extremely large, even a tiny amount of mass corresponds to a vast amount of energy. This idea completely transformed physics. Before Einstein, mass and energy were treated as separate conservation laws. Mass, energy equivalence unified them, showing that mass can be converted into energy and energy can be converted into mass. This principle explains how the sun produces light and heat. In nuclear fusion reactions at the sun's core, a small amount of mass is converted into energy, powering life on Earth. The same concept is at work in nuclear power plants and nuclear weapons, where energy is released by converting a fraction of atomic mass into energy. However, mass, energy equivalence is not limited to extreme or dangerous phenomena. It applies to everyday physics as well. For example, when you heat an object, its total energy increases, and so does its mass, even if the change is far too small to measure with current technology. Mass, energy equivalence also plays a critical role in modern particle physics. High-energy particle collisions can create entirely new particles, demonstrating energy transforming directly into mass. This process is essential to understanding how particles were formed in the early universe just moments after the Big Bang. In essence, mass, energy equivalence tells us that matter is condensed energy. It reveals a deeper unity in nature, showing that everything we see, from stars to atoms to our own bodies, is part of a continuous exchange between mass and energy. This simple yet profound idea reshaped our understanding of the universe and remains one of the cornerstones of modern physics.